Okay, so starting chapter 2, there is a lot of information, okay, with chapter 2 to get us started. So we're talking statements and truth values in 2.2. So first of all, we have a statement, okay? So the highlighter's not gonna be a good resource here, is it? We'll just stick to the pen. All right, so let's start with the statement there. In the study of logic, it's a statement that's true or false. Okay. Um, a lot of times this statement it's going to be symbolized up here. It says symbolized with a P or a Q. A negation is when we say not. Okay, a negation is not P, has that wavy sign in the P, or not Q is the wavy sign with a Q. And so it says it's red, not P and not Q to help you. The negation, right? We're looking at the negative of that. So let's look at this statement that they gave us though. Because again, a statement is in the study of logic, it's a statement is either true or false. So the Bible says, or the Bible is the word of God. That's true, right? So that's why we have the tree over there. How about the next one? 2 times 3 equals 9. It's false. It's 6. Okay, so we know it's false, and we could even put that it's 6. How about x plus 5 equals 29? Okay, so this one says it's not a statement because its truth can't be determined. Okay, so we have an in there, so it's neither is how we would put that. Because it would depend on what x is. We can't determine the truth. Has to be a statement. Correct. And then the next one says 8 plus 7 equals 15. That one's true. Okay, so just determining some truth or false statements. Again, a statement can be negated. Okay, that's what we looked up at the top where we had not P and not Q. That's how we would symbolize it. So a negation, though, always has the opposite truth value. So gold is a precious metal. Okay, so this might be P. And on the other one, it has a not in it. We negated it. So this says gold is not a precious metal. So this is not P. But it says it has the opposite truth value. So what's the truth value of the first one? God is a precious metal. Or gold, sorry. Gold is a precious metal. What's the truth value of that? Is it true or false? Or neither? It's true. Okay, gold is a precious metal. That's true. So if gold is not a precious metal, is a negation, and we know when we negate it, it always has the opposite truth value. What is this one? It's false. I'm sure it might sound like I'm asking you like overly simple questions that you think there's a trick answer to. I say we're doing the simple ones before we get to the hard ones. Yes. Okay. So then there are different parts. There's some to our statements. Okay. So first up, we're going to use these quantifiers. Okay. So quantifiers quantify a statement. So we have universal quantifiers. Okay. And those are all and every. And the symbol there is an upside down A. For the universals. So it's kind of like a U in the union, right, in set notation, but it's an A instead of a V or a U. Maybe that will help you to realize that it's all. It's unioning everything together. Universal, union, upside down A symbol for all. See if you can make that connection. The others are called existential quantifiers. So it's an upside, it's a backwards Z, right? Yes. Okay, so it implies one or more. Some or the words there exists. Those are existential quantifiers. And again, we're language heavy at the beginning of this chapter in each section, I feel like. All right, so then there's this awesome chart here that's going to help us. Okay, so if we want to kind of pick the chart apart so we understand every piece of it. Okay, so we have our universals are here and our existentials. Okay, these are statements. Our universals say all or every when they're positive. Okay, so we have all A are B, right? All Nikes are shoes. Okay, now if we do the negative of that, we're going to say no A or B because it's negative or negated, so we have to have that word in there. Okay, so that's a negative universal. So there's either all or no or none. In the existential, the positive of the existential is some A or B. So some rectangles are squares. Okay. The negation, or the negative of that, sorry, the negative of that is some A are not B. So again, our negative has a no, a none, a not. Usually the negative has, it has to have one of those terms. Now, the tricky part is in parentheses. The negations are indicated by arrows. So if you have a statement that says all A are B and you want to negate it, you're going to say some A are not B. Okay, because then the negation, when we negate, we're going to go back up here. When we negate, we're giving it the opposite truth value. So if somebody says all squares are rectangles, okay, that's true. If we negate that, we say some squares are not rectangles. That is not a true statement, right? It is false. So the negations are indicated by your arrows because you're going to come back and reference this probably quite a bit. Okay. Then let's put this into progress or like into action. Okay, so I'm going to keep that there. Example 1 says negate each statement. So the first one, there exists a student who gets straight A's. Okay, so hold on. So there exists a student who gets straight A's. So which one of like where does this fall in our chart? There exists a student who gets straight. It's a positive. Good. Is it a universal or an existential? Existential. Okay, so it falls right here. Ooh, let me get the pen. So it falls right here. It's an existential. If we want to negate it, we need to follow the arrow and write it like this. So the negation of P or the not P, right? Because this one's labeled P. Are we good with this? I probably shouldn't have put it over so far because I won't have room to write my sentence. Okay, so not P is going to be what? Instead of there exists, no students get A's. Or get straight A's? Yeah, let me do that. No student gets straight A's. No students get straight A's. Fantastic. So, and maybe we should have looked at it and said there exists a student, this is the A part who gets straight A's, and this is the B part. Okay, we might do that on the next one. Do we feel pretty good about this so far? Okay. So, let's do the next one. Oh, no. Okay, so let's look at the next one. Some pies are not cherry pies. Okay, so we're not worried about true. Where does it fall? So we have some pies, so this would be our A statement, our A, are not cherry pies. So cherry pies is going to be our B part. It's a negative because it's got a not in it. Okay, so is it universal or existential? Existential, right? Some A are not B. Some A are not B. Yeah, so it's right here. So to do our negation, we need to follow that one. So not Q is going to be, Lucas, can you tell me what it is? No, we get rid of the not, right? There's no more not. Our cherry pies. Because we're negating it. We have to follow. There's no not here, so we get rid of it. That's the negation, the opposite of it, because we're giving it the opposite truth value. Good question. So that's why we get rid of the not. Okay. Okay, so let's look at the next one. Good call. So no square is a circle. So where does that fall? Negative universal. Good. So no, we have no. So square is my A term. And what's my B term? Circle. Good. So the negation of R, not Q, because I already did Q. So the negation of R, we need to follow the arrow, is going to be right here. So we're going to say what, Justice? Oh, R circles. Correct. Some squares are circles. And that's not true, it's false. Right? All of our original statements were true, and we gave them all a negative or a false truth value. Okay? All right. Woo! That's a big step. I just want you to know, in logic for math, that's a big step. So you guys did fantastic. All right, next up, we have this truth table. It says, the truth table summarizes all possible truth values for a statement. And this is just a simple statement. So if our statement is P, our statement can be true, right? Okay. What's the other option? It's false. It's either true or false. That's it. Okay, now, then if we look at it this way, if we negate P, okay, if P is true and we negate it, it is now false. If P was false and we negate it, it's now true. Does that make sense? Awesome. Awesome. Did you say no? Oh, okay. I was like, did somebody say no? Okay. I was like, we need to clear it up. Okay. So now we're going to get into some compound statements. Okay. Whoops. Sorry, I'm trying to keep the sun off. Oh, that's better. Yes. Okay, yes. Compound statements combine simple statements with and or. Whew. Okay. So a conjunction uses and, right? Our conjunction uses and. So P and Q, it is denoted with this little like tint. So if it's an and statement, both simple statements must be true. So both must be true for the conjunction to be true. Okay, does that make sense? Let's see if it makes sense. Okay, so we've got our truth values because we've got two of them. So we have P is true and Q is true. What about the conjunction? Okay, they must both be true, so then this one would be true. Okay. Now what if P is true and Q is false? Then the conjunction is false. What if P is false and Q is true? It's false. What if they're both false? It's false. Ding, 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 ding. There's only one way for a conjunction to be true, and that's for both of them to be true. Awesome. Now, A disjunction is using an or statement. Okay, so it says P or Q, and this time it's denoted with a little V. Okay, so P or Q. So that kind of goes with that union. It can be either P or Q. We're combining them together, although it's a V instead of the U. So it is true when at least one of the statements is true. So we just need at least one. Yikes. Okay, so in that one, yeah, Justice, you're right. All of them are going to be true except for the last one because we have a true and a true, so it's true. A true and a false, well, one of them's true. A false and a true, one of them is true. Two falses, well, then we're finally false. Okay, very nice. So that part makes lots of sense. I like it. Let's look at example 2 then. True or false? Any 3 points are collinear, or the union of opposite rays form a right angle. All right, so let's look at this. It has 2 statements that are joined by what word? Say it, say it, say it. Or, okay. So there's an or in here. Yeah. So this, and then I wrote this little note here, right? Or is a disjunction. We just talked about that. So let's look at the 2 statements because that's where we have to go down. So what's the first statement? Okay, any 3 points are collinear. I'm trying to block this on there. Okay, so here we go. Any 3 points are collinear. Okay. Yes, that would be false, but so that's statement 1. Okay, and it's false. All right, let's look at, so then what's our second statement? So or is not part of our statement, right? That's the or. So the union of opposite rays form a right angle. The union of opposite rays form a right angle. Union of opposite rays. So if I have a ray here and the opposite ray goes here, that forms a right angle? No, so that's false, okay? So is this disjunction true or false? Why is it false, Justice? Both are false, right? It falls in this category right here. So we have statement 1 is false. Statement 2 is false. So the whole thing is false. All right, very nice. Okay, example 3 is going to be a fun one. No. What do you mean no? Tables can be awesome. Oh, yes. The table you're sitting at is a big table. All right, so it says make a truth table for P. What on earth is that symbol? It's a conjunction, which means what? And, okay. So we want to make a table for P and this quantity. See, this is why getting set notation down earlier was so important because we're using it again. Okay, and Q, what's this symbol? Disjunction, which is or, okay. And then what's this symbol? The wavy symbol. The not, okay. Whew, all right, fantastic. Okay, so here's the thing. I gave you all the possibilities for P, Q, and R. Okay, so if P can be true and Q can be true, then R, it can be true. Or it can be true, true, false. True, false, true. True, false, false. Okay, so that's the thing. We're going to look at what we need next. So yes. So the next column that we should do is going to be the not R because we are using a P here, a Q here, and a not R, and that's not in here. Yeah, we're adding to the table. We're going to have to add to figure it out. So this is going to be not R. Well, that's a terrible line, but oh well. So should have made those black. Okay, so let's look at, like we said, not R, it has, when we have the not, it has the opposite truth value, right? So if R is true, not R is false. So go through and fill those out. We have not done hardly any numbers. I don't think we've done any numbers yet. You're right. Yeah. No numbers. Geometry and no numbers. Who would have thought math with no numbers? All right, so let's read through these and make sure you got the right thing, because if you don't get it right, you're going to mess up your whole table. So we should have false, true, false, true, false, true, false, true. Are we good? Lucas is dancing in the back. I like it. All right. So next up, we need to focus on our or statement here. So up here, we're going to say, well, what is Q or not R? Okay, so just a second. Let's see if I can get my, can I pick a different color for a highlighter that might be better? Is it going to, okay. All right, so when we're looking at these, we're comparing our Q, oh, see, I kind of colored out, to our not R, right? Those are the two I need to focus in on. Because we're doing Q or not R. So an or statement, how many of them has to be true? One of them has to be true. Okay, so if we look at Q, so we have T and F. So then it's T. It's a V because that's that or symbol. So I just copied this part right here in parentheses. That's a Q, V, not R. So Q disjunction. So that or. Okay, if we look at the next one, right, our Q is T and our not R is T. So can you guys fill those out, you think? Yep. Okay. All right, Lucas, read us what you got. Let's make sure we have the same thing. Down the column. All right, we're good. Okay, so the last one is for us to do the whole thing, to look at the truth value of the whole thing. So P and Q or not R, truth value. So this time, let's see how my orange is. Okay, I'm going to use an orange. This time I'm looking at my P values, right? And this column of values here, the Q or not R. Those are the two columns I'm comparing now. What does my tint symbolize? And, okay, so remember it's an and so how many statements have to be true? Both, okay, both have to be true for it to be true. Okay. So the first one, I've got T and T. The next one I have T and T. All right, see if you can fill out the chart there. Okay, Justice, can you read me yours? Okay. F, 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 you said? Yep. Perfect. All right. Yep, and they both have to be true. Nope, because they both have to be true because it's a conjunction. So this one, no, because they're both true. It's true and true. So it's true because we're looking at this one. True and true. Yeah, I know, that's why it's tough. Like I had my paper highlighted, and then like this one's false, true. So that one is false. And this one's false, false. So it's false. I know. It's hard. It's hard to keep it straight. That's why. So yeah, I mean, like I get it because there's so many columns. You have to do so much work for each of them that I get that it's tough. And that's why, like in my notes, my notes are highlighted to help me know which one to look at. So uh, I get that. And that's why I do it here to help you see, like, okay, I'm looking at these numbers or these letters. All right, so on your own, state whether each statement is true, false, or not a statement. So you could put the in for neither.